aircraft manufacturing factory was established in 1975 to undertake manufacturing of a primary flying trainer aircraft under license from Saab Scania of Sweden. The aircraft was named Mashak, meaning proficient, and was produced from the kits provided by Saab. After successfully producing 92 Mashak aircraft, AMF acquired the status of Original Equipment Manufacturer or OEM in 1981. Within a short span of just 30 years, AMF has produced more than 300 Mashak aircraft, which are successfully flying not only in Pakistan but also in foreign countries such as Saudi Arabia, Oman, and South Africa. The Mashak not only meets the requisites of international aviation standards but also conforms to Pakistan and South African civil aviation standards. And that is why it is the frontline aviation product of Pakistan. During the course of manufacturing, AMF, in order to improve the design and performance, produced an upgraded version of aircraft in shape of Super Mashak. Equipped with Lycoming 260 horsepower engine, advanced avionics package, Garmin and Dynon glass cockpit, and side-by-side seating for instructor and student pilot, Super Mashak forms an ideal platform for a variety of roles. Short takeoff and landing distance, higher G-load bracket, excellent stall and spin recovery, and above all, excellent after-sales spare and structural spare support are some of the key features rendering Super Mashak aircraft to be far superior than its contemporary primary flying trainer aircraft of the same class. The aviation industry in Pakistan has experienced a tremendous growth in last 30 years. Over the years, AMF's stature as aircraft manufacturer grew manifold, with successive capability achievement to manufacture jet aircraft trainer K-8 in late 80s, unmanned aerial vehicle Falco in 2008, and the modern jet fighter aircraft named JF-17 Thunder. Today, Aircraft Manufacturing Factory has the capability of manufacturing structural parts and aerostructure assemblies such as the horizontal stabilizer, elevator, vertical stabilizer, rudder, and front fuselage of K-8 aircraft. Keeping abreast the evolving trends in aviation, AMF decided to venture in manufacturing of unmanned aerial vehicles through the latest carbon composite material processes. Pakistan Air Force, after a comprehensive operational and technical evaluation process, decided for establishment of Falco UAV manufacturing facility at AMF. During the first phase, 8 Falco UAVs were received in form of semi-assembled kits. The final assembly and system integration of these UAVs was successfully accomplished at AMF PSC Canberra under the supervision of OEM in 2007-8 timeframe. During the same time period, state-of-the-art equipment was also purchased to start co-production activities. After commissioning of the equipment and training on parts manufacturing, the newly established manufacturing facility was qualified by OEM to manufacture Falco UAVs on European quality standards. An aviation industry is considered at its pinnacle when it has the capability of manufacturing a modern fighter aircraft. Today, AMF has complete infrastructure, core capabilities, and state-of-the-art technologies for manufacturing of JF-17 aircraft. Machining Center for production of aircraft parts is equipped with state-of-the-art conventional and CNC machines. Parts with relatively lesser accuracies are manufactured on conventional machines, whereas complex parts involving higher accuracies and profiles described by higher order polynomials are manufactured utilizing the CNC machines, integrated with computer-aided design and computer-aided manufacturing systems. Sheet Metal Workshop for JF-17 parts houses an array of conventional and CNC machining facilities. Machines such as guillotine and nibbling shear, conventional and CNC stack routers, etc. are utilized for processes like shearing, routing, and sawing techniques, whereas CNC short peen forming, hydraulic quintus, fluid cell press, CNC stretch forming, and CNC punching, etc. are used for manufacturing of parts involving sheet forming processes. Pipe manufacturing, emerging recently as a separate technology of manufacturing, caters for the requirements of aircraft hydraulic, pneumatic, and oxygen systems. It involves pipe bending, end fitting, testing, marking, and covering. The most typical equipment being used in pipe manufacturing is CNC pipe bending machine. Special processes form an integral element of any modern manufacturing facility, as almost all sheet metal and machine parts undergo heat treatment, surface treatment, welding, and various other types of special processes during manufacturing. Vacuum oil quenching furnaces, air circulating and conventional furnaces, etc. are employed for heat treatment, whereas chemical treatment facilities include anodizing, chromating, bluing, phosphating, pickling passivation, electroplating, primer painting, and chemical milling, etc. Every manufactured part has to undergo a series of testing and inspection procedure from raw material till final stage at Material Testing Center. Material Testing Center has the capability to conduct all kinds of physical, chemical, and non-destructive testing of materials, including testing capabilities of all heat and surface treatment equipment for periodic qualification. The first phase of aircraft assembling starts at aerostructural build-up facility. Hundreds of sheet metal and machine parts, pipes, and components, etc. are skillfully put together with the help of thousands of rivets to build aircraft sub-assemblies such as fuselage, wings, horizontal and vertical stabilizers, and ailerons, etc. The aircraft starts to take shape at final assembly setup, where sub-assemblies, all system parts, engine, piping, cabling are installed and integrated before sending the assembled aircraft to flight test station for stringent power on and functional checks of each and every system of the aircraft. This is followed by a series of aircraft ground runs and quality shakedowns before finally handing over it to the test pilot for yet another series of functional check flights to ascertain the airworthiness. The manufacturing of JF-17 Thunder fighter at Aircraft Manufacturing Factory has brought Pakistan amongst select group of countries of aviation world. Attainment of this capability in less than a quarter of a century itself speaks of the highest standards of dedication that AMF engineers and technicians showed since the word go. Avionics setup of Pakistan Aeronautical Complex, known as Avionics Production Factory, was initially established as the Radar Maintenance Center in 1983 for overhaul and rebuild of ground-based radar systems. In 1989, it was transformed into a full-fledged avionics factory with ability to handle avionics as well. Today, this factory, with its state-of-the-art facilities, can undertake production of different types of avionics as well as commercial electronics equipment while ensuring high-quality standards as per the requirement of Aerospace Standard 9100C. The factory has produced numerous avionics systems like Grifo-7 and KLJ-7 airborne radars, radar warning receivers, identification of friend or foe systems, digital, audio, video and crash recorders, various mission computers and navigation systems. Most of these systems have been co-produced in collaboration with Chinese and Western manufacturers. The factory has also produced various commercial products such as PSE pad called Takhti 7, PSE notebook and e-book reader. The avionics production facility at APF can be divided into 6 major segments: design and development, avionics integration, production line, testing line, specific system department, and environmental stress screening facilities. APF can undertake design and development of avionics systems based on user requirements and provide complete solutions from concept to life cycle maintenance of the products. The prototype avionics systems are designed using computer-aided design and simulation tools. The prototype systems also undergo electromagnetic interference and electromagnetic compatibility and environmental qualification. Systems developed at APF have qualified and are flying on fighter aircraft. The developed system prototypes are functionally tested and integrated in the Dynamic Simulation and Integration Laboratory known as DSI. The facility can also undertake integration of off-the-shelf systems with an avionics suite. Being a certified avionics integrator with years of experience, APF has developed core integration technology for meeting requirements of new fighter aircraft and upgrades and modifications as well as retrofits in older aircraft. The systems are validated through hardware in the loop ground testing in simulated environment and are subjected to flight trials before final qualification. After successful qualification, serial production is undertaken utilizing semi-automated and automated machines. APF is a qualified production vendor for various companies, and its generic production line employs stuffing of surface-mounted and through-hole electronic components on bare printed circuit boards. PCB stuffing is a multi-stage process involving PCB inspection, cleaning, and drying before these are ready for components installation. The processed bare boards are then passed through automated assembly line which installs the components. Few components like connectors, etc. are however installed manually. The assembly line is configured to adapt to production of any types of PCBs. The completed PCBs are inspected using optical and X-ray inspection systems for faults before being passed for testing. The standard of workmanship during complete production process conforms to requirements of IPC 600 and 610D standard. Stuffed PCBs are passed to generic testing line for in-circuit and functional testing. These PCBs are powered on and tested to ensure serviceability of individual components and complete functioning of PCBs. The testers are adapted for testing any electronic assembly. The testing facility is generic and comprises of sophisticated test stations. APF has the expertise to develop complete testing solutions, including development of software programs and mechanical adaptations for testing. When PCBs have been stuffed with components and tested, these undergo conformal coating before being fed to specific system department. Here, these shop repairable units, along with other components, electrical and mechanical wiring, and harness assemblies are put together as a line replaceable unit for final testing of system. Since the processes require unique procedures for each system, there are separate assembly and testing areas for every system. Once a system is ready, it is passed over for environmental stress screening, where these systems are exposed to practical military environment with the help of thermal climatic chambers and shakers. The aim of this strenuous testing is to ensure that the equipment conforms to actual aircraft environment as per requirement of Military Standard 810D. The systems that pass through this process are guaranteed to perform reliably when put into operation. Avionics Production Factory also provides life cycle maintenance for these airborne avionics systems. Factory employs skilled manpower with years of experience in repairs. The facilities are equipped with latest test and measurement equipment, and repairs are undertaken as per international quality standards to ensure original equipment manufacturer specifications. APF also carries out overhauling and refurbishment of low-level and high-level ground-based radars, especially Mobile Pulse Doppler Radar known as MPDR. The facilities available with APF are electronics modules repairs and testing, cable and harness repair and manufacturing, which includes RF, signaling and power cables, antenna structural repair and testing, troubleshooting and repair of hydraulic systems, gear testing facility, and radar vehicle overhauling. Overhauling of radars give a new life to the old radars and are considered fit for operations for another life of 8 to 10 years. The factory has so far overhauled more than 90 MPDRs and TPS series of radars. APF has come a long way to acquire the knowledge and skill in the field of quality production and repair of avionics equipment and overhaul of ground-based radars, and looks forward to enhance this capability further to achieve the excellence.